able to make it today. So as Juliana mentioned, today I'll be giving you a little bit of information about some of the work I've been doing during my dissertation here at UVM and looking into some behavioral differences between species that I'm really interested in, the lake trout, and looking at differences between the naturally produced or wild fish and their stock counterparts. I'll also mention this has been a joint effort with some of the co-authors you're seeing down below at other universities, as well as with the U.S. Geological Survey. And then there's also a number of other folks who are helping out, have been helping out with this project, including my dissertation committee here at UVM. There have been numerous undergraduate assistants, as well as other graduate students in the Rubenstein Ecosystem Science Lab where I'm at, who have been able to help with this project. Vermont Fish and Wildlife has helped with some of the capturing, and then also some other agencies. Also, I'd like to give a big shout out to Sure Strike Charters. They've been great with helping us capture some of these fish that I'll be talking about, and allowing us to really look at these behaviors. As Juliana mentioned, Sea Grant has also helped with this project by providing some funding, in addition to other organizations, including the Great Lakes Fishery Commission, who's made funds available through Senator Leahy. A little bit more about myself. I'm a fourth-year PhD student here at the Rubenstein Ecosystem Science Lab. It's actually where I'm presenting from today. Prior to coming to UVM, I did my undergrad and master's in Western New York at SUNY Brockport, where I studied salmon and trout in Lake Ontario, doing some food web analyses, looking at some vitamin deficiencies that were going on out that way. And overall, I studied fish ecology with my research interests really focused on behavior and food web interactions. And ultimately, this leads into this idea of conservation, which brings us back to this topic today. And looking also at fish behavior in a way of looking at conservation. And so this video here is just showing an example of fish behavior. These are lake trout during their spawning season, which occurs in fall. And we can see these mating pair here. It's a female in front followed by a male, and just them swimming around this area. And this is a great example of fish behavior. However, this is a fine scale behavior, looking at what these fish are doing at an exact moment in this really great area. Whereas I'm going to be presenting today on more broad region-wide behaviors. And this is really important because Lake Champlain has seen a lot of changes in the past couple of decades or past couple of centuries. And these include changes to the watershed. So there were things like deforestation. The image here on the right shows, you can see it's a log drive on the White River in Vermont. And so almost all of Vermont was clear cut by the late 1800s. And this caused a lot of sediment to then go into the tributary and ultimately end up in places like Lake Champlain. We have also seen a number of introduced and invasive species. To date, there are 51 known introduced species, including things like the zebra mussel that you can see on the figure on the right here now. So that the figure here is showing some equipment that was deployed in the lake. And this is within 1 year, it's completely covered in these zebra mussels. So they can have drastic impacts in the system. If you imagine that everywhere along the bottom, or essentially everywhere along the bottom, these organisms are able to occupy, you can have a dense mat like this with these mussels. And then lastly, one that folks are probably more familiar with or hearing a lot, climate change, where we're seeing increased water temperature in the lake. We're also knowing that there's greater storm intensity. So if we have a lot of rain, you have a lot of that rain becoming runoff and then ultimately ending up in the lake, creating things like the sediment plume on this figure. This is from the Otter Creek, which is one of the tributaries in the southern part of the lake. And you can see there's a lot of stuff that's getting dumped out from this creek into the lake. And that brings with it things like contaminants, other nutrients that could then lead to other issues such as harmful algal blooms. And the lake trout themselves have had a challenging history in Lake Champlain. Historically, they were one of the main offshore prey fish, or one of the main offshore predators feeding on prey fish. They were extirpated or removed from the system by unknown causes as early as 1900. One thought for why this might have occurred was commercial fishing. However, because they are this offshore predator, they occupy deep habitat, they really like cold water, there probably wasn't much of a commercial fishery. And we know that actually there haven't been any records of any commercial fishery for lake trout in Lake Champlain. So some other ideas are things like spawning habitat degradation. While these fish occupy that deep offshore water throughout most of the year, when they come to spawning period in the fall, they tend to move near shore. And at this time, they'll spawn over some habitat like you're seeing in the figure here, where it's this nice rocky substrate that allows their eggs to fall into the cracks between those rocks and then be protected. However, because this is all near shore and they require these these cracks between the rocks, if the sun from that logging events, if those cracks fill in, then it can cause some damage to the spawning habitat, the lake trout spawning habitat. There's also sea lamprey predation that's been known to cause issues with lake trout populations, where this is an invasive species that can suppress lake trout populations. The lamprey they don't directly kill lake trout, although they can, if they have enough if there's enough predation by the sea lamprey. But this is just something that can really influence the lake trout populations. And then lastly, just something about lake trout in general is that they're a very slow growing fish. They mature after about 5 to 6 years of age, and they can live over 50 years. And so if you wipe the species out, or if you really decrease their numbers, it can take a lot more time for them to come back, and it can be a lot more challenging. So one way of getting around these decreased fish populations, whether it's lake trout or other species globally, is with stocking programs. And in Lake Champlain, there are hundreds of thousands of fish that are stocked every year. Just this past year in 2022, there were 500,000 Atlantic salmon that were stocked, as well as 57,000 lake trout that were stocked in the system. And this is important because fish are valuable for many reasons. There's a societal value to these. They have subsistence farm or fishing, recreational and commercial fisheries. Just shows how this can really be something that's an impact, or it's a value across generations. And it's something that we're going to continue to have into the future. There's also a lot of ecological value. So these organisms support natural processes that maintain balanced ecosystems. And then also the natural value, where these organisms have an intrinsic right to persist. So stocking programs have reintroduced lake trout. Like I mentioned, they were removed from the system by as early as 1900. Stocking programs began in the 1950s, and then those programs really ramped up in the 1970s when it became annual. We're able to distinguish stocked fish from any wild fish because these stocked fish have this fin clip. So if we capture a fish, it's missing a fin, we know that that was produced from the hatchery. There are some error rates with this. This is all done by people, and they're doing tens of thousands of fish every year. You can imagine there's an occasional fish that gets missed. And this is all very small fish. They're only a few inches in length at the time that this clipping is done. So these are really small fins. And so there's about an accepted about 4% error rate with this. So fish have been stocked for over 4 decades now. And we know that there was a lot of spawning that was going on in the lake. These adults are going out, they're going to different spots in the lake, they're depositing their eggs, but the wild fish were still largely absent. And that's what we're seeing down here in the figure on the bottom right. So this is looking at the percentage of unclipped lake trout. So that means that they have all of their fins. And this is starting in the 1980s for recent years. And that dotted line before represents that kind of error rate that you can imagine. And really in the recent years, you can see everything's been below that error rate. So while there have been some unclipped lake trout that were detected, those were likely stocked fish that had that missed fin clip. Prior to about 2000, we're not entirely sure why those numbers were higher than 4%. It may have been something where there were occasional wild fish here or there, but more likely it was just the practice of clipping fish just wasn't really as enforced at that point. Jump forward to 2015, we have the first observation of wild juveniles. And that's what you're seeing now, this new figure, where we're seeing multiple year classes or formed in different years are naturally produced. So this was a great sign. We're seeing these fish are coming back. And jump forward to today, these lake trout are really rebounding. We've had over 10 consecutive years of wild fish production. So that's great. To 50% of the adult fish in recent sampling are wild. There are also multiple wild adult year classes that are now contributing to the spawning population. And all of this has led to management actions where there's been recent reductions in stocking efforts. The first reduction was a couple years ago. You might have just heard about the press release, the reducing the stocking numbers for lake trout again. And this is all great progress for creating a sustaining population. It has been present in Lake Champlain for over 100 years. But there's still questions. Why did it take over 40 years for these wild fish to show up? We started stocking them in the 50s and then really ramped up that stocking in the 70s. And it wasn't until 2015 that we're starting to see these wild fish. Why was that delay? Also, now that these wild fish are back, how can we best manage the lake trout? And so to get at this question, both of these questions, we can think about What are the differences between these stocked and wild fish? And if there are any differences, can that give us some insight into why it took so long and what can we do in the future with this population? And a big thing to consider with these two populations is that they're coming from different origins, the two lake trout populations. You have your stocked population, which grows up in habitat like you're seeing on the left here. They're having food provided to them. And then you have your wild population, where it's a completely different environment. And these different environments have things like different temperatures, different food availability, there's different densities of the fish, and different habitat complexity. This really gets important because we know that behaviors at early life stages can have lifelong impacts on animal behavior, or experiences at early life stages can have lifelong impacts. So, for example, if you learn behaviors that are specific to your environment at that early stage, things like optimal responses to local stimuli, that is then going to be a behavior you might carry with you. Also, fish hatcheries also cause this inadvertent domestication, where we're selecting organisms that are based on the interest of us as people rather than what's best for the organisms in the wild. And as I mentioned, this can have irreversible lifelong consequences. And a great example of this is with natal habitat imprinting. And if you think of salmon on the West Coast, they're born in these streams, they recognize characteristics of the local environment, then go out to the ocean for a few years, come back to those same streams because they were able to imprint on the characteristics of that habitat. And so if you're imprinting on something like a hatchery setting, then you might go back in the future to look for something like a hatchery setting rather than that more natural setting. Coming back to Lake Champlain, we know that the juveniles have different behaviors between the stocked and these wild fish. And there's differences here based on that rearing environment. These include differences in their foraging behaviors. So things like the success, how often are they feeding on things, and also what's the composition of their diet. We know that there's differences in their metabolic demand. So think about energy depletion. How much energy do these fish need? Where these stocked individuals are going through this energy reserves a lot more quickly than the wild fish. And then lastly, knowing that there are differences in their habitat use with different spatial distributions for the stocked and wild fish. And also not just thinking about where they are throughout the lake, whether it's north or south, also thinking about the depth that these fish are using. This is a three-dimensional habitat that these fish have access to. And for the rest of the talk today, I'll be focusing on this habitat use component. But rather than looking at it with juveniles, we're now wondering with adults, do we see these same behavioral differences that we see with the juveniles as adults? And so our main prediction is that there will still be these differences between behaviors based on their distribution throughout the lake. So where are these fish showing up? That vertical distribution, what depth are they using? And then also the amount of movement that these fish are making. Lake Champlain provides an excellent opportunity for this, not just because we have these populations of the lake trout here, but also because it's this complex system with multiple different basins. And these basins have both natural and artificial barriers. The figure here is showing the Mallett's Bay Causeway, many of you are probably familiar with, that separates Mallett's Bay here in green from the northern part of the main lake in this dark purple. There's also a lot of environmental variability in this system, things like depth, or in the where you can see differences in things like ice cover. And so this can all lead to different habitat conditions that fish can respond to. And then lastly, Lake Champlain has a number of great islands, as well as submerged islands, what we're calling these lake mounts, that might serve as optimal habitat, not just for lake trout, but for other organisms. There might be food for the adults, as well as food for the offspring that the adult lake trout are producing. That might make these habitats more suitable for the survival of their offspring. And the way that we're actually tracking these fish is using a technique called acoustic telemetry. And this allows us to passively track these organisms, where we're taking these transmitters, like you can see in the figure on the bottom, and we're surgically implanting these into the body cavity of the lake trout. We do a couple sutures to sew up the incision. And those transmitters a unique signal once every 1 to 2 minutes for up to 3 years. Another unique characteristic of these transmitters is that they can have pressure sensors. And so from that pressure sensor, we can then know at what depth that fish was at. And these transmissions are detected by stationary receivers that are placed throughout the lake whenever a fish is within range. And that range is typically about 500 meters. So when there's a fish that swims within about 500 meters of a receiver, it'll send off a signal, says, I'm here, I'm here. So we know at that specific time, that fish was at that exact location. And we also can have sometimes the depth that that fish was at that point in time. As far as the number of fish that we tagged, there were 38 stocked adults and 15 wild adults that we tagged. And 16 of those stocked fish had pressure sensors, and 10 of the wild fish had pressure sensors. And the figure here on the right is just showing the distribution of these tagged fish with their total length in millimeters. And while there's a difference in the size, the cutoff is everything above 500 millimeters that we're considering adult. So we expect the behaviors of these fish to be similar. The receivers were placed throughout the lake. There were 60 receivers that we used, and we targeted specific habitats, things like transition points. The figure here is showing that causeway again. You can see there's a small opening that allows boat passage as well as fish passage. So we're putting receivers on either side of this opening. We can see how these fish are moving between these different regions. We also targeted known spawning sites. Some previous work has done a great job documenting where lake trout are spawning throughout the lake, so we can see if there's any differences in the distribution of these wild adults at those sites. And then lastly, these lake mounts, like I mentioned. While this isn't the exact at this location, it just gives you an idea that this is at least one spot where we're seeing these submerged islands or these lake mounts. And we have a lot of interest to see if they actually do have any important ecological function for lake trout. And it's also something that might be useful for other species. So we've gone out, we've tagged all these fish, we have all these receivers in the system. Now what we get to do is actually visualize what these fish are doing. So this is a figure that's showing the movement of 8 different wild fish throughout the lake over time. So you can see that timestamp on the bottom is just showing where these fish are over time. This is really useful because we can identify shifts, not only in where they are and coordinate positioning, also thinking about their depth and what regions they're using. You realize that it just picked up a lot. The speed is increasing a lot. Lake trout spawn in the fall. This is the time of year that they're looking for either mates or good spawning habitat. So this really has great use for identifying what these fish are doing and where they're going. Now we're going to dive into the results. And this figure is looking at habitat selectivity. And this is a way of looking at how much fish are using a region relative to the amount of availability of the region. And that's what the equation on the right here is showing. And so we have this selectivity that ranges from a value of +1 to -1. If a value is at 0, that means that an organism is using that habitat as much as it is available. Values greater than 0 mean that they're selecting that habitat, and values less than 0 mean that the organism is using that habitat less than it is available. This is looking at one season, just right now it's looking at winter. And we're also looking at 5 different regions of the lake for both stocked fish in purple and then the wild fish in green. And for this season, the main takeaway is that the central and southern parts of the lake are really being used. And then there's a few fish that are using the Mallett's Bay section. So there's a small bay during winter. And then the north section is being used as much as it is available. Next, when we look at the spring, we see similar patterns, although now that Mallett's Bay use has really dropped down. And this makes sense because Mallett's Bay is a shallow habitat. These fish need to get out of the system before summer when temperatures really get warm and there's not any suitable habitat for them. So when we look at summer, you can see Mallett's Bay is still low again. We have a lot of use of the Maine Central and Maine South regions, and then the Maine North, not used quite as much. And then next, when we look at the fall, so this again is the spawning season, we see still that the central and southern parts of the lake have a lot of use. The north part of the lake, the stocked fish are using it as much as it is available, while the wild fish are not. And then the eastern basins, the Inland Sea and Mallett's Bay, really aren't getting used that much. So main takeaways from this is that we do see similar patterns between these stocked and wild adults. They're using the central region and also the south region most consistently, and these eastern regions, the Inland Sea and Mallett's Bay, are somewhat rarely visited. When we focus on the spawning season, there is one interesting difference that sticks out here, where the north part of the lake the selection for north part of the lake differs between the wild and stocked fish. Now we can look at that more closely with this figure. That's just showing on a map, where are these locations? So the dark blue represents habitats that are preferred. The light blue means that there's no preference. The white means that it's not used. And so just for the stockfish at this point in time, and we're seeing that, as we just saw, there's a lot of preference for the central and south. And then the northern part is being used as much as it's available. Wild fish, the big difference is that they're not using that northern part of the lake. We can look at this at a finer scale rather than looking at by regions, by the actual receiver locations. We'll just jump. So this is just summarizing what I was just saying. So both the stocks and wild fish prefer the central and south regions. The stockfish are the only ones that are really using that northern part of the lake. So when we look at this at a finer scale, this is actually the receiver locations and how many fish are using those sites, and then also how long are they staying there. So the number of fish, or the percentage of tagged fish that show up, is indicated by the size of the circle. The larger the circle, the more the fish that are present. The color represents how long the fish are there. The lighter the color, the shorter the amount of time, darker the color, more time. So the larger the circle and the darker the color, the more important the site. And this is specifically for the spawning season. So a larger dark blue circle is likely going to be a spawning site. With these stocked fish, we see the central part of the lake has a lot of importance, as well as the north and south. In contrast, when we look at the wild fish, the central part of the lake is still important, but the north and south are a lot less important, especially the north. And so again, the north and south regions here are really just used by these stocked adults. And what's really fascinating about this is this northern site. So right off the shore here, there's the Edweed Fish Hatchery, and water from this hatchery comes down through a creek. It's called Hatchery Brook, comes right out into the water here. So where I was saying that is that the central region seems to be extremely important for lake trout. We see not only the wild fish there, but also the stocked fish there. So there's something going on there that's of great importance for this population. Next, we were looking at the depth that these fish are using. And again, I'll go by season, and the stocked fish will be in purple and the wild fish will be in green. This is depth in meters. So if you're not too familiar with meters, a rough estimate is to multiply the values by 3. And with lake trout being a cold water fish, when it's cold out in winter, they have access to the whole lake. And that's what we're seeing here. The dark points represent individual depth data for the lake trout, and just gives you an idea of the total range. So we're seeing fish that are practically at the surface going down to 120 meters for the stocked fish. The wild fish don't go quite as deep. However, most of these detections are occurring in those bands that you're seeing, where we're at about 10 to 30 meters at this time of year. When we jump over to spring, this is a time when the lake is going through some temperature changes. The lake is warming up. So at the beginning of the spring, we're really cold, fish have access to everything. That's probably why we're seeing a lot of these detections or this data at these shallower habitats. They have access to this shallow habitat. But towards the end of the spring, the lake's a lot warmer. Lake trout are now moving offshore into the deeper habitat. And that's why we're seeing this large peak in this deeper habitat here. Jump forward to summer, the lake's the warmest it's going to be. All of these fish are now really deep. And so the shallowest that we're seeing is really anything. There aren't many fish that are showing up shallower than 20 meters. So everything below that. And a lot of these fish are really concentrated right above that 40-meter mark. But again, they do have access to that deeper habitat because everything is still cold below 40 meters. And then lastly, fall. This is another period where the lake's going through some changes. The beginning of fall, things are going to be really warm. The lake trout are going to stay deeper. But then as temperatures cool, the lake trout start to move near shore for their spawning events. And that's why we have this larger peak now as well in this period. So this table is showing just the averages, where these fish are showing up, what depths they're showing up based on these different seasons. One of the main takeaways is that we do see these seasonal differences in the depth use, where really during the summer, these fish are going a lot deeper. But then also the wild fish are generally using less vertical habitat. And you can see that in this variance here, where the stocked fish have a much higher variance than the wild fish. And you can see this in the plot as well, where the stocked fish have a greater number of depth use at these deeper habitats. Next, thinking about the movement. So we know there's not many differences between the organisms based on their habitat use as far as depth. But how about how much they're moving around different times of the year? And what this is just showing is the average daily movement. So how much is an individual fish moving in a day in kilometers, different seasons, again, separated by these stocked and wild. And this table also shows us as well with the average number of kilometers moved. And we're seeing that there's a lot more movement in the fall. And you can kind of see that here where they're moving 1 to 2 kilometers a day, whereas previously they were only moving about half a kilometer a day. And you kind of saw that before in that animation. These fish are moving around a lot more quickly. So the next thing that we did was we separated this out. I'm sorry. So the wild fish were moving around about 40% more than the stocked fish during the fall as well. So there's a difference here between the stocked and wild fish. The next thing that we did was we separated this out by the regions of the lake to see if we still have this difference. And like before, we're still seeing that the average daily movement for the wild fish, if you look at the X's as well as the boxes here, the boxes for the wild fish and the X's are slightly higher for the wild fish than they are for the stocked. And this information is based on positions with centers of activity. And there's an animation here that's going to explain what I mean by this. So imagine the blue circles are our receivers, and this red circle is a fish that's been tagged. As that fish swims throughout the lake, it gets picked up by receivers. And imagine this is a 1 hour period. So within that 1 hour period, this fish showed up at those 3 sites. And the center period or location for this fish, or the center of activity, is represented by that X. So now we jump forward to the next hour. This fish swims around again, shows up at this northern site 2 times, the southern site 1 site. And so it's an average position. And so we're seeing that this fish moved to this other position. And the distance moved is the distance between those 2 X's. And again, we're seeing that these wild fish are moving around a lot more within regions, anywhere from 30 to 160% further than the stocked fish. And we do see some differences across the regions here, but that's likely due to differences in where these receivers are placed. Some receivers some regions have much higher receiver coverage than others. So it's gonna appear that there's a higher daily movement because we're getting more detections. However, one issue with this plot is that there's a lot of values right at that 0 that are really hard to distinguish. And it's these zeros that are actually driving a lot of these differences, where the stocked fish are moving around less. So there's a lot more zeros for the stocked fish than there are for the wild fish. Another way of thinking about these zeros is that it's the amount of time that the fish are staying in one position. That's what we looked at next, was the average number of daily detections at a receiver. So if you're at a receiver longer, you're going to have more detections there. And so this is kind of the opposite of what we saw before, where wild fish were higher than the stocked. Now the stocked fish are higher than the wild because the stocked fish are sticking around longer. This was calculated based on the number of detections within a 1 kilometer range. So we're going to have a similar animation as we had before. We have a fish swimming by, spends a lot of time at the north site, not much time at the south site. So we have this X position. Say the fish does the same kind of thing the next hour, but it's a little bit further down to the south. It's not really a big change in the habitat. So these things get grouped into one region or one location, and we're looking at the total number of detections within that 1 kilometer range. Here, what we're seeing is that the stocked fish had 35 to 105% more detections in these 1 kilometer positions. So again, indicating these stocked fish are sticking around a lot longer. And so all in all, what does all this mean? Well, we know these lake trout move around a lot. Individuals are commonly using different regions of the lake throughout the year. And we also know that the vertical distribution varies seasonally. And this can be important because when we think about the differences between the stocked and wild fish, if you're a stocked fish and you put all of your eggs on this one site and that one site doesn't turn out to be too good, your contribution for the wild population in the future years is going to be really low because all of your offspring aren't surviving. Whereas if you're a wild fish, you're traveling, you're going to a bunch of these different sites, you drop some eggs on this one site, you drop eggs on another site, you have a higher probability that some of your offspring are going to survive and therefore contribute to the future wild population. We've also learned along these lines that origin matters, especially during the spawning season. We're seeing that stocked fish select different habitats. So, for example, I was showing how the stockfish are all showing up at that northern site along that break wall. And if that site doesn't allow offspring to survive for some reason, we have a lot of stocked fish that are using that spot and not having any contribution to the wild population because if they're all of their offspring might be dying. We also see that these wild fish might be using more spawning sites than the stockfish. So that's what I was saying before, and how that can really have some impacts on the future of this wild population. There's still some questions though. We still don't really know why it took over 40 years for the wild fish to appear. Maybe it's just something that they needed time. The stocked fish that were put into the system needed some time to move around a little bit and find these sites where offspring could survive. And because most of these wild fish or most of these stockfish are staying at just a couple positions, just a couple spawning sites, that might take a lot longer than if these fish were spawning on multiple sites. But we also don't know what makes spawning sites successful at this point. It seems like there's something special about the central part of the lake where all these wild fish seem to be spawning as well. And so there could be some research that looks into what are the characteristics of those habitats? Is there something that differentiates them from something like that northern site? And is there something that we can do to create habitat that resembles these successful spawning sites? It's also important to know how many wild fish are in the lake right now. While that's not something that I'm specifically looking at, there's other researchers that are lab here that are looking into that question using some genetic approaches. And Sea Grant is actually funding one of those projects and hope. We also know that this lake is going to continue to change in the future, and there might be maybe other things that influence lake trout populations. Things like new invasive species. There's a couple that are right on our doorstep, the round goby and quagga mussel. We imagine that those species are going to have impacts once they get into the system, like they've had in other systems they've already invaded. So we have other researchers at the lab here that are looking into those questions. Speaking of questions, I think this is the point where I'll thank everyone for coming, but also I'm happy to take any questions. I know there are some people that weren't able to make this presentation live today, but it will be recorded. So for those folks, if you'd like to ask me any questions, feel free to email me at the email listed here. Also, if you have any interest in what our lab is doing, we have a lab Instagram page where we post a lot of information about the research that's going on at the lab. With that, I'd like to thank everyone again for being here today and also thank Sea Grant for funding to help make this project possible.